talking talk a little bit about the future of blockchain and why it's important, and why I think it's, having a base understanding for everyone here today is actually a kind of a key part of knowledge of, how the world is changing and how data is such an important part of society. So a little bit about me. I have actually an engineering background, maths and physics, kind of got sucked into the startup scene. I'm the type of guy that walks around with a copy of Wikipedia on my memory stick, because I like to say I'm a little bit of a data wizard, and that's also why I wear a wooden bow tie. I'm not kind of the usual standard of the meal type human, I guess. But anyway, what I'm going to do is I'm going to share my screen, and hopefully this is going to go seamlessly. Can everyone see my screen? I'm looking.
Yes, so we can see your screen. Just a reminder, if you have any questions, just ping me or Clemens, or you can just ping in the Zoom chat.
Super. So the topic of this talk is everything blockchain except the hype. And before I start, I just want to tell a little bit about Blockdata, super short. So that's where our research has been featured by, some large news outlets where we've done research into the development and kind of, development of the blockchain ecosystem. And the way that we conduct that research is we've actually collected a lot of data inside our platform. Now, this platform we've been building for over 2 years. We founded the company in early 2018. And the reason why we founded the company is, there's a lot of pricing information out in the ecosystem. There's more and more on-chain information of what's happening on these blockchains themselves. But there wasn't really a place where we could go to actually research the entire ecosystem and understand what these products, these platforms, these companies are actually engaging with. So that's why Blockdata exists. We're happy that we serve some large corporate clients, and we've also worked for 2 out of the big 4 consulting companies where they came to us to actually explain to them blockchain, which for us was a very big compliment. So getting into it, I always feel it's really important to start and by not going so much into the future, but looking into the past. And that's because history, when we're talking about technology, when we're taking this really cliche quote, history doesn't tend to repeat, but it very often does rhyme. So that's where when we're looking at blockchain technology, what we can see is it's really followed the Gartner hype cycle curve that we probably all know here today, where in 2017 and 2018, we were really in this peak of inflated expectations where everyone was running around saying, hey, cryptocurrencies, it's the future. We've then entered into 2019, this trough of disillusionment, and now we're moving into this slope of enlightenment. And I hope that the data that I'm going to show you later on is going to help validate that. Another model that I've also got a lot of inspiration from, and I always encourage everyone who's working in technology to understand, is the intersection between technological revolutions and financial capital. So what you can see is we have this maturity of the previous technological and financial kind of surge, and we have this new surge of new technology that goes through these 4 standard phases. Eruption, the invention of the technology, in our case, this is 2008 with Satoshi Nakamoto, this frenzy phase, this synergy phase, and this maturity phase. Now, what's interesting is that where we are right now with the development of the technology, and also where we are with the state of the world, is we're really moving through this turning point, not only in terms of finance, but also in terms of technology. I'm going to be talking about this later on as well, but I think this graph here for me summarizes why it's more important than ever for people to really start to understand what's going on. And that's also the world is more complex than ever before. And that primarily is, the amount of data that is now being generated from all aspects of society, business, and governments is just, it's exploding every single year. And I really like this quote, which is from the EU, from their recent data strategy, which is their roadmap for the next 10 years, is they define data as the lifeblood of economic development. I just want to leave this up so everyone can internalize it a little bit, because basically what this is saying is data is key to the economy. It actually represents the economy, and all business processes, no matter what industry you're operating in, all of them use data. The EU goes on to saying, over the last few years, digital technologies has transformed the economy and society, affecting all sectors of activity in the daily lives of all Europeans, or anyone around the world. And data inherently is at the center of this transformation, and more is to come. Now, data, as with all these business processes, inherently moves through various systems. And what we see of how the economy is structured currently is, as transactions and data kind of moves through these systems, different entities and organizations take cuts of the fees effectively to then verify that data. They then transfer that data, or they make decisions off of that data. But one of the biggest things with data itself is the standardization of it has been a huge issue, as only in the last 100 years have we moved from paper-based systems, then into these mainframe systems, and now into these huge globalized multicultural environments with platforms like Facebook that serve a significant portion of humanity. And that's where companies like SAP, you know, they've been, how can I say it? Like, they've been paid millions and billions of euros to help companies manage data, but that's where the data has always been so effectively centralized in the way that they're managing it. And if we take that and say, okay, well, how does a transaction work? Is there's these various parties that are always involved. And this here is a representation that we made in one of our early researches of a cross-border payment transaction. So we go from a sender who sends a request to a sender bank, which then goes to a payment system, correspondent bank. We then have foreign exchange to the corresponding banks, payment banks, receivers banks, all the way to the receiver. And this is a long, lengthy process. And the reason why it's long and lengthy is at every single stage, the companies need to verify that that data is correct. Is that allowed? Is that legal? So every company here, every process has a very defined set of rules that all of these companies need to effectively abide by. And that's why the economy has been structured like this. If we look at something like SWIFT, for example, and the role that they play in the global economy, they effectively sit in the middle where all of these other entities that want to do a transaction always have to reference this trusted third party, and then they need to settle these transactions. But it's not just in finance where we're looking in terms of trusted third parties with processes like MasterCard, but even Amazon at this point is a trusted third party where actually what they're coordinating is data between buyers and sellers, obviously the logistics involved, the postage providers, etc. But also even a company like Facebook is effectively, it's a peer-to-peer marketplace, if you will, not necessarily of actual value, but of messages, of data that are going from one person to another. So if we actually look at what data is meant to represent a source of truth. Now, if I'm Facebook and I'm collecting that data, I know myself that that is a source of truth because I was the one that collected it. But if I sent it to another party, or if we're talking about money and I send money from person A to person B, I still need to verify that that is true. And that's what a lot of these back office jobs have been doing in these large financial organizations, is just verifying these sources of truth. But data en masse can produce facts and statistics that can be collected together for then reference and analysis. But very traditionally, these companies have, you know, effectively hoarded their treasure trove of information and data. And so saying once again, data is always untrusted until it has been verified. And that's what these third parties also offer, is they offer that trust, that verification. And so this raises two questions. What if data that's representative of you is controlled by someone else? This is becoming a hotter and hotter topic as technology becomes a bigger and bigger part of our lives. And it also asks the philosophical question of, does it need to be this way? Now, I think when talking about blockchain technology, please don't shy away from the philosophical aspects of what it is trying to, bring to society. Because if you're really only looking at it through a business lens, personally, and I think this is also representative of what we see at Blockdata, you might actually lose some of the true possibilities that are applicable with this technology. And the last thing I want to say about data is that we've all heard about the fourth industrial revolution and all of these new game-changing technologies, but that's where, if we actually look at them and categorize the three biggest ones, if we look at AI, that is great at interpreting data. If we look at IoT, it's great at generating data. If we look at artificial augmented reality and virtual reality, it proposes a new way for humans, that's you and I, to interact with the data. But the question then is, where is the data management technology in all of these radical game-changing technologies? Because they all work with data. We all know that there is a lot of data, but we need to be able to trust that data. And that's then where we get to blockchain. And blockchain, in essence, simplified, is just a ledger. And I am going to be simplifying a lot of what you hear today. And that's because, there are so many metaphorical rabbit holes that you can go down with blockchain, depending on what specifically you're looking for. And I'm hoping that what I'm about to tell you serves as a very good frame of reference. We're going to go through this next part, and then we're going to take a little break if there's any real burning questions, and then move on. So, blockchain as a data management technology. What does data management actually enable? Well, it's all about keeping records. These are records of transactions, monetary transactions or message transactions. These are records of ownership. Who owns that house? Who owns this asset? As well as records of certification. So for example, when you will graduate, you're going to be given a certificate, and we all know that a paper is all good and well and has been the way that we've been doing it all the way up until today, but having digital certification can actually, ensure higher levels of trust. And if we look at these three main archetypes of records, they are key again to any business and any business process. And every single company has gone through this upgrading from paper of their data structures. And now, looking at the frame of blockchain, we're moving to the next evolution. And when I say that, what I want you guys to get out of it is basically this. Instead of one entity now saying what's right or what's wrong, we are now creating a shared set of truths, which everyone can look at, everyone can both read and write to, and we all agree that this is a shared set of truths. And what this enables us to do is to start to build and maintain a common understanding of the world around us, and effectively have data lakes that we can all trust and access. So still haven't explained what blockchain is super yet, but that's where but it's really about the ideas. And that's where, if we go back to how the economy is currently structured, where everyone is referencing this trusted third party, what we're in essence moving to is where, instead of using the word blockchain, we prefer to use the word trusted layer or network ledger. So what this basically means is this trusted layer that sits in the middle, all the different parties from potentially anywhere in the world can all read and write to one central place. And it's up to that trusted layer, and no longer the entity behind it, to enforce the rules and ensure that it is the most accurate information that is presented. So we're going from trusted parties to trusted layers, or as everyone likes to call it, blockchain. Or another word is network ledger. The terminology in this ecosystem is one of the most frustrating things about it, but over time, we're hoping that it's going to get better and better. So if we look at what the actual primary benefit of this technology is, if we go back to that example transaction that we made for a cross-border transaction, we now see, instead of all of these parties, what a sender can do is they can interact with a wallet or just one entity, and they then transact in one central place that enforces those rules. which then sends the money or the transaction over to the receiver. Now, another example of this is the human resources industry or organizations. And what we can see is that there are many different departments and entities that need to interact with one organization, from different departments: performance management, operations and technologies. We have project coordination, clients, client consultants, recruitment consultants, interviews, talent assessments. And what we see is these organizations, every department has had its own data structure, and they all need to be interoperable with everything else. And not only that, but when they want to pass information, not only from their organization, but to another organization, they also need to shift that data structure again. Whereas if we're looking at a blockchain base, just keeping it really simple, we just have one place in the middle where all participants can read and write to that place. So one of the things that's really important with blockchain is you really have to remove everything that's been spoken about with Bitcoin, because it's all too often when we're explaining it to our parents, we're like, hey, have you heard of blockchain? They're like, oh yeah, it's that Bitcoin thing. And it's like, no, please stop. So that's where it's not just about currency. But if we're looking at transactions again, it's about sending a message, issuing an educational certificate, or even as simple as updating the status on shipping. Because when you get that notification on your phone where that parcel is on its way, it's actually just a ledger entry that's saying the status of that package has changed from state A to state B. Now, from our point of view, the simplest way to define what a blockchain is, and this is one of the key things that I'd like everyone to take away from, is don't go into trying explaining blocks and blockchains and hashing and Merkle trees and all of this thing. It's just this simple three-step process. So we have, when we're defining a blockchain, is we start with base number one. What are the rules in this digital environment? Then, what is the implementation? What software are we using in this digital environment? And what network? Who are the participants that are agreeing that that implementation is the correct implementation of the rule set that we like? Now, I know this is maybe a little bit weird, so I want to provide a different example. So in the physical world, if we treat the planet Earth as kind of, you know, this shared layer that we're all using, where an action like hitting someone is a record entry, what we have is we have a rule set, which, for example, would be the US Constitution. It's a set of rules that all the participants on the network need to agree with. Then when we're looking at implementation, that's, for example, the US legal system. How do you interact with the courts? You know, you have to actually go somewhere, you have to use these rules, you have to use the, built environment that is around that rule set of the US Constitution. Now, we won't be going into whether this stuff is actually being abided by in the US, it's just meant to be an example. And then we have a network of people that agree that that legal system is the correct implementation of that legal framework. So when we're actually then looking at blockchain-based systems, what we're actually trying to understand is a couple of things. So when we're talking about the rule set, we start with some basic questions that we need to answer. What is the consensus mechanism? So that's, how is the network coming to a consensus on what's right or what's wrong? What data are we looking to store in this blockchain? What permissions do we want to give to this blockchain? What are the economic rules that can create economic incentives for actual participants to use this system? And one of the most important ones is also the governance of this system. You know, who sets the rules? Is it everyone? Is it only one person? These are base questions that if you in the future are going into a conversation in a company and you're looking and someone says blockchain, these are the key 3 pillars you need to be able to get in depth into. When we're talking about the implementation, what software are we using? Why are we using that software? What benefits does that programming language give over something else? Who's running which part of the infrastructure for this blockchain? And then the network is really, who's using this blockchain? What incentives do they have? Why are they using it? Sorry, some background noise. So to get a little bit more in depth into kind of why these how these blockchains actually work, to give two basic examples, that's where we're looking at consensus. And consensus is really important in these blockchain systems because we're trying to coordinate actors that fundamentally don't trust each other, thus they're trustless, to come to an agreement on what transactions are allowed or not allowed. Now, the Bitcoin network uses a consensus mechanism called proof of work. Now, I'm not going to go super in depth, so I'm going to majorly simplify it. But basically, that's where various machines, which are called miners in a proof of work ecosystem, they solve mathematical problems. And when they get it correct, they get rewarded. That's the economic incentive. And in order to secure the network, there is the basic rule that the more miners there are on the network, the more secure the network is. When we look at proof of stake, which is what Ethereum is going to be moving on to, that's where a staker, someone that actually wants to validate the next transactions, they can lock up a certain amount of their currency or some form of value into the network. And then they say, okay, well, I'm going to get rewarded if I validate the next batch of information. And the more stakers in the network, also more secure the network is. But hang on a minute, how does this work? Well, if I'm a staker and I do something that's against the rules of the network, then my stake can be taken away from me. And the reason why that's relevant is obviously you don't want that to happen because then you're going to lose your economic incentive. Now, these are just two, and they're not the ones that are the best ones. There are no best consensus mechanisms that currently exist at the moment, and these are huge mathematical algorithms that are cryptographically extremely complex, and over time they are being innovated on more and more and more. Oh, I'm going a little bit quick here. One of the big questions that we've come across in the blockchain ecosystem is about anonymity. So the basic way to frame this is, if I know the address that someone is basically, sorry, backtrack. Like if I know the address where I am today, which is Herrengracht 221, do I actually fundamentally know who, for example, lives here? Well, I can see that I can actually see the address where that person may live, but I don't see that person who actually has the key to that house. Now, the reason why I'm explaining this is it doesn't matter what type of blockchain network you're using. Whenever you interact with it, whether you're an individual or you're a person, you're always given a unique identifier that is a public key. That's much like the address that you or I have at our homes or in our office. You then also have a private key that when you put the two together, it allows you to transact and take actions from your assets that you own within that network. Now, when we're talking about anonymity, because the addresses are all public, that's where it's only when, I don't want to say this, I'm getting a little bit mixed up in my head. It's only when someone actually goes and interacts with it and unlocks it, is there some form of identification. Now, when we're talking about regulation in the blockchain ecosystem, because of the way the addresses are structured, it fundamentally is anonymous, as in I don't know who actually owns that address. But when we're talking about regulation, for example, AML5 directive that's here in Europe, before an exchange can actually send money from the exchange to my public address, the regulators say, well, you need to know who that address belongs to. So you have to go through a KYC procedure where your ID is sent to the exchange, and then the exchange will then transfer you the money. Now, this is important to understand because there has now been an identification moment in the network where the exchange now knows, okay, well, Tim gave me his ID and he then sent money to this address, and thus I can deduce that that address belongs to Tim. And if that wallet ever makes a transaction again, if that address ever makes a transaction, I can always attribute that back to that identifier of Tim. Now, this is not bulletproof because I could give my private key to someone else and then they can do a transaction with it where they might re-identify in the future. But this also brings to an important topic when understanding blockchain networks, which is the conversation between permissionless or public, and permissioned, which is private chains. Now, this in essence is effectively kind of a battle between the ideals of a public blockchain crypto ecosystem in this anarchist kind of Bitcoin world and the corporate adoption. Now, the reason why that is a corporate doesn't want all of the transactions that they're making being public to everyone around the world. So effectively what they do is they close up the ecosystem and they say, if you want to interact, one, you have to give your identity, like what we saw on the slide before, or two, and then secondly, we have to give you permission and we have to say, okay, you can actually go and make an address, or you can actually go and participate in the network. I also want to point out at this point that, for everything that I'm saying, there is a lot of information online where you can go much more in depth. I'm just trying to give the most high level information here. Now, smart contracts, they've also been, hyped in the ecosystem. They're kind of like, wow, it's smart, it's amazing, the future is all on smart contracts. Well, I just want to make it really real and bring it down a level. A smart contract is just like any other code, where code is effectively, if this happens, then do X, or then do Y. So if X, then Y. But the nice thing about a blockchain environment and why smart contracts are very interesting in this specific use case is when you're running on these blockchain networks, the data that is contained within it is trusted because it's already been verified. Going back to that very beginning where I was talking about how companies are verifying this data. So that's where a smart contract, if it sees that a data point within it has, executed X, if X is there, it doesn't ask any questions. It doesn't have a bias, maybe, well, actually that's not true. It can have an inherent bias in the algorithm, in the smart contract, but it just executes. It just executes. And that's where there are efficiency gains that can be made by first creating this trusted data layer and having this trusted data, and then applying smart contracts on top. All right, this was a super quick, because there's a lot of information in here, into kind of like, without trying to get into the technicals of blockchain, but really kind of what are the mental models that you can be looking at when thinking about blockchain. I'm gonna have a glass of water. Are there any like really big burning questions?
Before we continue, there's one question that came in. Can you elaborate a bit more on the algorithms to ensure consensus among the trustless parties? How is the data verified?
I'm trying to think. Lucas, you want to come and help with this question?
Yeah, sorry?
Can you repeat the question? Because I'm trying to think of the simplest way to answer that.
What was the question?
Yeah, so the question is, can you elaborate a bit more on the algorithms to ensure consensus among trustless parties or verifying the data?
In the simplest way.
In the simplest way. Yeah, not being a developer myself, it really is just a mathematical formula that adheres to certain rules and elements from different parties that's already made by a contract or a predetermined contract. That's my understanding in probably the simplest of terms of how an algorithm can justify or verify a trustless blockchain, if this makes sense.
So yeah, if you go, so going in, like one of the key things of kind of one of the key aspects here is a topic called hashing. So that's where how much information can you take and can you verify into one auditable string. And this is something that, this is also used in the storage of your passwords, for example. And I'm trying to not go too in depth. Maybe, yeah. I think let's park this for now. Otherwise, we go down a rabbit hole.
Sure.
So yeah. All right. So next, I wanted to talk about actual blockchain adoption. And this is kind of really going into what I hope, will at least open some eyes in regards to what's happening in the blockchain ecosystem. Once again, there's going to be there's a lot of data that's going to be in these slides, and all of this is available through all of our public channels, but you'll also get the slides afterwards. So as a basic introduction, we see that blockchain adoption is no longer tomorrow, but is really heating up. That's where these three stats for us really validate what's going on in the ecosystem and also where it's going to go in the future. So Gartner's saying 3.1 trillion in terms of, blockchain business value by 2030. Deloitte, in their 2019 survey of companies that do more than $100 million in revenue, they said that 86% of them said that blockchain is broadly scalable and will eventually achieve mainstream adoption. Outlier Ventures did research, and they said that $23.7 billion worth of capital has been invested in blockchain technology since 2013. It's at this point that I also want to try and make the differentiation between cryptocurrencies, which is one of the applications of blockchain, and blockchain technology itself. Now, if we're looking at crypto, the best way to think about it is kind of like this new financial infrastructure that is decentralized, or AKA decentralized finance, DeFi. And that's where, for the first time ever, currency has traditionally been defined as a system of money that's used in a particular country, whereas now we have something that is globally, it doesn't differentiate between country or borders, but it's truly global. But from an institutional perspective, looking at cryptocurrencies, there's been a big hurdle to, one, trust it and ensure that it's safe. And the price is still very volatile and unstable. That's where we personally believe that Bitcoin as a store of value is probably one of the safest places where you can actually have these assets and currency right now. And that's because, unlike a financial institution, if I want to go and take out all of my Bitcoin and transfer it, I can do so whenever I want, whereas at a bank, that might not always be possible. The topic of a bank run is more and more relevant right now. In the ecosystem, there's the idea of verify and don't trust. And that's because the information that's available in this decentralized crypto ecosystem, you can always verify where the money is going or how much you actually have. You're not just trusting the number that comes out on your bank account when you open the app. And what's more and more interesting is, as we're seeing over time, is effectively more and more applications are coming out where they're creating effectively the Lego bricks for a financial world that exists effectively in the cloud and owned by no one or owned by everyone. When we're looking at blockchain use cases, that's where it really is about this data management. And it's about creating the shared set of truths between various parties, no matter what the data is meant to be contained in that transaction. And that's where companies are sharing control of the network. There is also an increased shared trust in that information. A couple of blockchain projects, crypto projects that might be relevant, because we're now going to focus on the crypto aspect, is there's Ethereum, EOS, and Komodo that are all blockchain platforms. So these are really, the kind of where they store all the information, and they really focus on what are those rules, the implementation, and the network. But what you can then do is, using smart contracts and other things that you can build on top of these networks, is you then have layer 2 solutions. So for example, Decentraland is really building a blockchain-based virtual world on top of Ethereum. MakerDAO is trying to be the world's first stable, unbiased currency, also built on top of Ethereum. And Basic Attention Token, where they're doing digital advertising. Again, advertising doesn't really have too much. There is an exchange of value in terms of the currency that's being done with the Basic Attention Token, but it's really about the attention and how the data of users interacting with these adverts. That's really the transactions that are happening. So these are some that I think, just having a quick look at these will kind of bring you up to speed with some of the more notable companies in the space. If we look at the growth of the ecosystem using some compound annual growth rates, this is from A16Z, Andreessen Horowitz from San Francisco, and they've been looking at not only the price, but also the amount of social media activity, developer activity, and the startup activity in this space. And what they're saying is they're hypothesizing that actually the growth of this crypto ecosystem is really connected to the price of Bitcoin and other assets, where they say the higher the price goes, the more innovation that will come into this crypto ecosystem as more people want to get involved, just like any other market cycle that we've seen before. One of the big issues with the adoption of cryptocurrencies, which is truly the biggest issue of cryptocurrencies, has been, you can't use cryptocurrencies in a transaction if they're incredibly volatile. If Alice wants to, buy some bread from Bob and they agree that it's worth 10 euros, and then by the time the transaction is made, or just even 10 minutes after, the value has now dropped to 9.50 euros, someone is not going to be happy in that transaction. So one of the solutions that really came in, well, firstly in 2017 and really, hit the peak in 2020 was lots of companies and I would say groups of people came together to try and create something called stable coins. Now, a stable coin is relevant because what they're doing is they're effectively digitizing things like the dollar. So in Tether, which is the very first one, what they did is they said, okay, well, I'm going to make $1 worth of I'm going to take $1 and put it in a bank account, and then on Ethereum, I'm going to issue one Tether token, and I'm going to say that those two are now linked together. There has been controversy in this because some people, have not believed that Tether actually does have those dollars in their bank account. And that's where in the ecosystem, why a lot of information is generally open source is because people want to be able to verify that the claims that these companies are making are actually true. One of the interesting things about stablecoins is Ethereum was promised to be a decentralized global computer. And that was meant to be kind of why Ethereum was special. Whereas if we actually look at the market activity that's taking place on this public blockchain, we can see that actually 80% of the value of the transfer that's happening inside the network is actually just from stablecoins. So what's interesting about the crypto space is we're not only, a company might start a blockchain project or a group of people with an outcome in mind, but other people are then looking at it and saying, hey, well, this is actually really useful for one of my use cases. And collaboration in the blockchain ecosystem from the developers and the, let's say, anarchists that believe in this is really like nothing we've seen before. That's where now, in terms of the amount of dollar value that is now in these stable coins, it's reported to be $8 billion worth. So there's now $8 billion worth of dollars that are now theoretically sitting in a bank account somewhere that can now be used to transact inside these crypto environments. Going to remittance, as I showed those charts earlier, we can also see that companies and startups have effectively looked at this technology where they've said, okay, well, if I want to transfer money from someone in America to someone in India, I don't want to use these old suppliers like Western Unions because I now have a tech stack that I can build this on that can be a lot faster. And, when we did research into this, we can see that, Western Union, in terms of their average transaction times, 3 to 5 days, and you're paying $9.7 in fees. Now, those fees, again, are used because there are so many parties involved in the process. But if we go down to Bitcoin, we see the average transaction time for making the transaction is 1.3 hours, and the average fee you're going to pay is 37 cents. Now, this fee also does change. This is depending on how busy the network is, and is something that is also one of the downsides of the ecosystem. These blockchains can also become quite clogged up. Going a little bit into BAT, what's interesting about what they're trying to do is they're really trying to build an entire ecosystem on top of their token. So that's where you have users that are rewarded with tokens for their attention. You have advertisers that are paying using tokens to reach those users. And also, as users earn tokens, those tokens can also be given automatically, if you choose, to publishers that are publishing information. What's interesting about BAT as the token is that it has something called the Brave browser, but the Brave browser, when you actually start using it, it's just like any other web browser. And this is something that over time, this crypto ecosystem is kind of really striving towards is how do you make the usage of these tokens and the platforms as easy as possible and as much like the platforms that we are all used to using every single day. There's no reason why there can't be a decentralized version of Uber, but the reason why it doesn't currently exist is because it's just too complex to be setting up your own wallets. You also then need to have the economic incentive for users to switch over. So these are all, you know, examples of problems that should be solved over time. What's nice also about that is the last reported metric was 8 million users, which was in, I believe, 2019. But I think there was some news recently that it's now the most popular browser in Japan, apparently. But we'll see how this evolves. So corporate adoption, the hottest topic at the moment. This is a chart that's from McKinsey, and I also put the link here. If you just Google McKinsey blockchain, it's one of the most in-depth, I would say, web pages really going into depth on all the different aspects of blockchain. But they did a review of, you know, where's the feasibility of the ecosystem, as well as how high is the impact of blockchain in these industries. Now, what we see is the feasibility in finance, for example, the public sector, and technology, media, and telecom is effectively, yeah, the highest rated across both metrics. That's where more and more in the news, we're starting to see that specifically in the financial industry, that there's more and more money that is being moved away from the traditional infrastructure and being put onto blockchain-based infrastructure. So these are some recent headlines. DLT ledgers being a blockchain platform. The supply chain platform has been in production and has processed more than $3.3 billion worth of deals. HSBC has recently put $10 billion of private placements on a private blockchain, that's R3's Quarters blockchain, and they also want to move that up soon to $20 billion. Lamborghini, looking at a use case that's outside of finance, you know, they're releasing blockchain collectibles for their sports cars to track authenticity. And something that came out yesterday is Shopify, which is, you know, one of the biggest e-commerce providers for SMEs, is now going to be accepting cryptocurrencies versus third-party provider coin payments. So these are the types of headlines that we look at where we see, okay, adoption, you know, if this would have happened in 2017, who knows what would have happened to the ecosystem, but where we are today, these headlines are becoming more and more repetitive. From a corporate perspective, I think it's really interesting to look at how they've been looking at blockchain. The first thing that corporates thought and what we heard from everyone was blockchain won't affect me. I don't need to worry about blockchain. That was in, you know, 2016, 2017. Then the corporates turned around and said, hey, well, how do I make money with blockchain? That's been one of the more, you know, it's hard to monetize this technology, and we'll get into that later. So then they started saying, well, how can I save money with blockchain? Then, you know, that goes hand in hand with how do I get the benefits of blockchain? And where we are today is the biggest question that we see from corporates is, who can we collaborate with? Who can I collaborate with to have a blockchain network? And that's where what we're moving towards is this word called co-opetition. So collaboration is happening between business competitors in the hope of getting mutually beneficial results. I'm sure you guys know a little bit more about this than I do, but it's really interesting to see how the blockchain ecosystem has really started to embrace this. But for example, we've been in a conversation with human resource organizations where their CIOs were sitting in the same room and we're giving them a presentation, and they're literally all looking across the room at one another, where they're all still looking at each other in a competitive mindset. So corporates have been looking in a few different ways of how to innovate with the technology, either internal development, getting assistance from consultants, you know, BCG, McKinsey, Deloitte, all of these consultants are now specializing in blockchain, not for one-off projects, but they are looking at it to create effectively subscription-based revenue to provide services to these blockchain solutions over time. Then there's innovation from service providers. The best company that's been doing this has been IBM. IBM a few years ago picked out blockchain and they said, this is going to be the direction that we're going in. And now they're really starting to reap the rewards. Or there's joining a consortia. Now, consortia being a group of companies that are coming together because they believe that a network inside their industry will not just provide benefits to one company, but can provide benefits to all companies. So the way that the three main themes that we've seen have happened is one company develops a blockchain solution internally as a use case, and then they maybe spin it out into a consortia, or multiple companies come together to fund and innovate together, where they all agree blockchain is the future. Or one company goes to a consultant and a service provider, which then in turn goes to other companies to lead the process. The best example of this has been TradeLens, which I'm going to talk about in a minute. What we're starting to see is that there are some really big players in the space that a lot of companies are partnering with to effectively get the benefits of it. So R3 and Hyperledger, that's where companies are going to them and saying, hey, well, we want to help you develop the base blockchain infrastructure ourselves, so we can be connected to the innovation in the hope that these will also support the industries in the future. But we can also see things like the Energy Web Foundation, the JP Morgan Information Bank Network, and we also have here the Financial Blockchain Shenzhen Consortium. Now, I won't talk too much about Chinese development with blockchain, but all I want to say is it is light years ahead of any other nation when it comes to blockchain. Here, what we see is some of the consortia that are innovating in trade finance, where you can see companies like ING are actually joining multiple consortia, where they're doing that because one blockchain tends to be focused on one specific region or one specific network of companies around the world, and they want to make sure that they're connected to all of these to have global coverage. It's been very interesting to see that the actual peak of these partnerships being formed and these consortia being formed has been in 2018 and 2019. And we'll see how these evolve in terms of what's happening with COVID. It's still too early to tell. If we look at another data point, which was a list compiled by Forbes, where they did the Forbes Blockchain 50, we can see that players like Samsung are providing infrastructure to the ecosystem. We see that Google is doing analytics on the ecosystem, Shell getting involved in energy tech. We have Baidu that's also getting into finance and banking. Amazon has also been a player of providing services to supply chain and logistics blockchain platforms. So it's interesting to see how large corporates are now really moving into the space. And more importantly, we now see, for example, with Honeywell, they were initially skeptical publicly of blockchain technology. And a few months ago, they announced, actually, we now have one that's in production and we're using it a lot. Things like BMW also moving into pilots now. We're seeing that the kind of next generation of platforms is starting to be released. If we also then look at, this is a network graph of the companies that are in the Forbes Blockchain 50 and what blockchains they're using, is we can see that quite a few of them are working on Ethereum, being a public chain, and we then have permissioned ones like Hyperledger Fabric. Now, I do want to note at this point, blockchains that are private, like Hyperledger Fabric and the other Hyperledger, Sawtooth, and other networks that they're building, as well as Corda, they don't all exist on the same blockchain as blockchains like Ethereum and Bitcoin do, but rather a group of companies can spin up their own private blockchain for their own use that doesn't share information with other blockchains. That's something to bear in mind. One of the things that we've been looking at with high amounts of interest is capital markets. And this obviously being the finance industry, we have things like asset tokenization. So how am I taking my asset, for example, coal, and how am I making a digital representation of that in a blockchain network? How am I doing clearing and settlements? That's where Euroclear and DTCC, these manage in excess of $50 trillion worth of securities for the rest of the capital markets infrastructure. And they're effectively looking at this. And we've had many conversations with Euroclear where they actually realistically looked at the technology and they said, well, if we're meant to be the company that's verifying all of these transactions and now blockchain verifies these transactions, what's our role? As a very open question. And these are also increased questions that corporates have been asking themselves is, well, if our service can be replaced by these blockchains, what is our position going to be? It's also potentially one of the reasons why Facebook did Project Libra, but also why Facebook has not announced, that they want to move their entire infrastructure to a blockchain-based system, for example, because it would disintermediate them by default. Going to TradeLens, if we look at this real-world application, they have these numbers on their website where they've already recorded over 1 billion events. They've processed 9 million documents and processed 22 million containers. And they're aiming to, quote unquote, transform container logistics by freeing yourself from legacy data systems, manual document handling, and poor visibility. But so let's say that they came up with these rules, which Mask, which was the original initiator of TradeLens, they went to IBM and they said, hey, can you help us build a blockchain platform? They went ahead, they worked together, they conducted some pilots, and it went great. And now where we're at today, which was also pulled from their website yesterday, is you have more and more ports and terminals that are actually using the TradeLens platform to process these documents and process all of these ledger entries, where the processes, the business processes that are involved, as you can see, involve many different parties with many different shipment data, as well as the documents that are necessary in these transactions. So again, this is not necessarily just finance-based. This is looking at how am I creating some form of digital twin of the information to transact through all of these different information all of these parties. And the last thing I want to talk about real blockchain adoption is when we're looking at central bank digital currencies. This is something that I encourage everyone to try and keep their pulse on and try and keep it, see what's happening as it's happening, because 70% of central banks are exploring central bank digital currencies. And if we just take 4 of the major economies, so the dollar, the US, the People's Bank of China, being China, the Europe being the Eurozone, and India, if central banks would issue central bank digital currencies, that's almost half of the world's population that suddenly the infrastructure that they're using to transact has shifted from this old way of looking at it with cash to this new way. And if that would happen, and then things like interoperability become really important, where that money can flow into other blockchain systems for specific use cases, it could potentially be one of the keystones or the major unlocking moments to really get the benefits of blockchain technology. Now, something that happened yesterday, which I think is really dope, is the French conducted their first digital euro test at the Bank of France, and they're focused on wholesale at the moment. Now, there is a difference with central bank digital currencies between wholesale and retail. Wholesale being bank-to-bank transactions, and is really like business focused, and retail being for example, you and me. Now, that's where what's interesting with central bank digital currencies is, what's happened in the US at the moment with them issuing debit cards to all of the all of the people that are getting kind of universal basic income, if we want to call it that way. If everyone would have a central bank issued bank account number, which would just be one of those blockchain addresses or addresses that I mentioned earlier, it would be ridiculously easy to start issuing a universal basic income to all participants, where because it's on this blockchain-based system, you can also then see what people are actually doing with their money. And this brings me to kind of one of the biggest things in regards to the future of blockchain is China's use case, to be really blunt, with blockchain technology is the fact that they can now see what everyone is doing with their money by default. And this is something where the EU is being a lot more skeptical of the technology and treading a lot more carefully, is they're trying to take into considerations things like privacy, which is really, really important that we think about. So that's where China, despite being light years ahead of blockchain, they're doing it because it actually gives them much more insight into how the economy is running. And that's because now all the information is in one central point instead of being in all disparate parts of the ecosystem. I'm going to get through this last part and then we can take any questions. I wanted to talk a little bit about, why is this really important now? Why are we at a pivotal moment in terms of blockchain technology? Well, I want to start by, saying what the size of Wikipedia is. The Wikipedia is effectively, you could argue, the most concise version of human knowledge that currently exists. And here we have a representation of how it would look in traditional encyclopedias if it was printed. And it's 16.9 gigabytes. And, anyone can reference it. It's a shared source of information or a shared source of truth. But it's, for what it is, it's actually not a lot of information in terms of size. But that's where, if we look at the amount of data that's currently, is predicted to exist around the world, what we see is, if we look at 2023, which is 100 zettabytes, that's 1 billion gigabytes worth of data. And this data not only has to go somewhere, but if we go back to this original premise that data always needs to be verified, it needs to be structured, it's this topic of data management is becoming more and more important. And this number that I didn't format correctly here is meant to be, 100 zettabytes is 5.9 million versions of Wikipedia. It's just not necessary. So this is the shift that we see that is going to happen, where we move from the traditional economy, which contains these dumb assets, these like basically paper certificates, where trust is enabled by third party, where we have a lot of information asymmetry because it's stored in many different places, where the aim is now, and this is why in finance it's really starting to happen, is we move over to the digital economy, where we have smart assets, where trust is provided by network consensus, by those consensus mechanisms that I mentioned earlier, where we get information symmetry. And we're now at this part in terms of the bell curve of innovation, where we're now moving from these early adopters to the early majority. And this chasm is what we're in right now, and it may take 6 months, but I think it's going to take at least a year or maybe even 3. And what the aim is that if there's $127 trillion worth of assets that's currently enclosed in the traditional web architecture and the traditional economy, is that we move those assets and migrate those assets into the digital economy. And again, referencing what I said at the very beginning through history, this type of thing is not new. And it is something that even the BIS, which is the Bank of International Securities, the central bank of central banks, they predict that these socio-technological systems will all start to shift because it is just the requirement due to the inherent limitations of the traditional technology. What I also want to point out here is that what is required for the turning point to happen is a financial crash. What have we just happened already this year? What has COVID led to? It might actually be one of the key drivers behind blockchain adoption, because more and more people around the world are realizing that the way that we've done things before, especially if you look at the top performing stocks in the stock market, they have too much control when it comes to refining raw resources, but it's not oil, it's now data. But 2 things are required for this technological revolution to actually happen, for this to be the future. And regulation is one of the key things that the regulators with blockchain have been taking a very watch and wait approach, which is now starting to change as we're starting to get more clarity. And there's an understanding and a perspective shift, which I hope I'm doing to everyone on this call today, fingers crossed. So this is something that will evolve and hopefully is starting to now pick up the pace. And the EU, this is the last few slides, the EU expects that we're not going to have one blockchain or one data network that's going to rule them all, but rather we're going to start with finance. And then we're going to get the supply chain on board, agriculture, energy, manufacturing, public administration, mobility, and health. And these data environments inherently are going to be innovated by private and public partnerships, where hopefully the regulation and the direction of these regulators will push the adoptions of these technologies but also the companies have to move from this competitive mindset to this co-opetition, as I mentioned earlier. And in summary, as humanity relies more on technology, the data underpinning it, the data that you and I interact with every single day, must be trusted. Because that's where effective resource management, because the Earth only has X amount of resources, should fundamentally be the aim. And that's where the digital environment, we must remember that we take information from the physical world and put it into this digital world. And that digital world can then provide services to better improve the physical world. And so if that's the aim, but all technology requires data, it's arguably getting more important than ever that we start to rely on the data that is included in the digital world. So I guess the closing statements that I want to say is blockchain inherently might be complex, but what I want everyone hopefully to take away today is it actually simplifies a lot of the stuff that's going on with data management. And we're now approaching the next phase of this technology. And I think the philosophical question for all of you is, what are the effects of better data, better managed resources on the job market innovation and potentially even the future of humanity?
Thank you, Jonathan. Thank you for the sharing. I hope now everyone, you all can show off your blockchain knowledge in interviews with parties. And some of this question is, now, you convinced us, we love blockchain and we want to work more on it, we want to do research. And you've mentioned that you're thinking about opening student projects. Could you share more about that?
Yeah, so we're thinking over the summertime to get some support from students on our cause, if you want to put it like that. We're still defining the exact projects that we want support on, but we discussed with Christian and the rest that we will share this with the group to see if anyone is interested in supporting us.
Cool. And now we've had loads of questions through the chats, through private chats. So let's see. I hope we can clear this off and finish on time. Now there's a question regarding miners. I didn't get what the miner is for, especially if it doesn't involve cryptocurrencies.
Yeah, so in correct me if I'm wrong, but in private chain solutions, when you're looking at things like proof of stake, you don't need to actually have miners, but rather you just have consensus nodes that store the information of effectively the blockchain. And through that, when you're looking at these private chain solutions, every company effectively has one copy of the data. They use something like proof of stake or even maybe an auditor, and they are the ones that are generating and validating the information. The topic of mining is really only necessary when you're talking about proof of work and other proof of work like consensus mechanisms.
Okay, so it doesn't mean that every blockchain will need a miner.
No.
I hope that answers the first question. And then the second one is, what are the major differences between different blockchain solutions and where are these coming from?
I think that every blockchain solution has trade-offs. You might trade security for, like the ability to have faster transaction times, for example. You might trade off some of the governance. You might trade the speed of a consensus mechanism, also again for the speed of processing of the networks. But from a corporate perspective, you're really looking at what are the business requirements for the blockchain to operate within my specific use case. And that's where you can think of the base blockchains themselves as, how do I want to say it? It's kind of like a, how do I want to say it? It's like, it's one aspect of the ecosystem. It's kind of the core of it, but whatever you build on top of it or around it is dependable on your specific use case. And that's where these base blockchains are designed, that they can accommodate a wide variety of use cases. But that's where if you go in one direction, you might not be able to use another part of the system.
So that's the pros and cons from specific solutions, right? How about the functional downside of using blockchain technology as a whole? Like what's the downside for corporates?
Well, the downside is that it's a very expensive maneuver, right? As much as it will try to weaken costs and reduce power, it's a very expensive integration effort from traditional mechanics to actual blockchain mechanics. And that's the biggest problem and the biggest limitations for a lot of corporates not wanting to do it. They're kind of waiting for the first player to actually adopt it and actually come towards a successful case. So I think that is probably the biggest limitation. It costs a lot of money, as much as we like to say. It allows things to happen fast. It allows for cheaper transactions, quicker transactions. The whole integration procedure itself, again, is very expensive. So this is probably the biggest limitation for a corporate.
And also, once you do it, once you've pressed that final big red button where you're no longer transacting on your traditional infrastructure and you start doing it on a blockchain-based infrastructure, it's if something goes wrong in that infrastructure, because all the records that go into a blockchain are effectively considered final, there's no undo button. That is one of the big things. It's like, I can imagine if you're a corporate, you're effectively shitting yourself when you make that move, because you're like, I really don't want it to work. Sorry, not to work. And one of the big things is in regards to governance, which is one of the biggest issues in the ecosystem right now, is let's say I'm a bank, let's say I'm a banking consortia and there's 20 participants. Let's say my blockchain breaks down on a Sunday afternoon at on Sunday 3 a.m. How do I contact all those 20 participants to get them to update their code that can rectify the mistake at 3 a.m. on a Sunday? Like these types of questions have never been faced by companies before.
Yeah, and I think to add to it, it's a little bit of the innovation dilemma, I would say. Like, are you going to improve the systems that you know? Or are you going to completely shift to a system that you don't know that probably will have an impact on a much later date? And that's a question that's not an easy one to answer for anyone in the innovation department.
How about scalability? Because we've known Bitcoin is one of the widest network, and I've also worked with a blockchain project before, and the transaction per second is much lower than what traditional systems are able to do. Like, has that changed? Is there any improvement on that point?
From Bitcoin's perspective, no. So for example, EOS, they employ a different consensus mechanism that again has trade-offs, but allows them to do much higher TPS. And that's where the amount of security, if we say Bitcoin is the most secure, is because that's where the amount of processing power the amount of complexity that's required in getting consensus to verify those small amounts of transactions is very high. Whereas in a blockchain where, for example, you are the only participant, right? It's just your company, like that's still theoretically possible. You might not care so much about that processing power that's necessary to go into verifying these transactions. So thus it could be much quicker.
Yeah, and scalability is an issue, especially for old chains, especially for Bitcoin, because you're looking at over 10 years of recorded data. So it's incredibly long, and that's why the transactions are very, very long as well. But of course, that paves way for a lot of innovation, especially Ethereum. So Ethereum 2.0s, which are developing new sharding, new scalability solutions that are actually, of course, trying to make these transactions per second a lot faster. It remains to be seen, though, if these networks, should they become the size of Bitcoin, will actually reach up to their potential by saying they can maintain those 100,000 transactions per second, 200,000 transactions per second by the recorded data that actually happens over the years. So there's a lot of test cases, there's a lot of stress testing that actually prove these fast transactions or these scaling solutions work. However, it still remains to be seen if it will fully operate in a very large ecosystem, if this makes sense.
We got the quantum computing question. Great. So quantum computing is, I love this question so much, and I'm a real asshole about it, but we should be much more about quantum computing for the entire structure of the internet than we can specifically for blockchain technology. Because quantum computing fundamentally breaks all encryption across everything. So I do agree it is one of the things with blockchain technology that does have an impact, but there are blockchain projects that are working on quote unquote being quantum proof, but you can claim that you're quantum proof, but until a quantum computer is really accessible, you know, it's a little bit of a catch-22.
That sounds like currently it takes a lot of processing power to process blockchain transactions. And how do we minimize the environmental impact of using blockchain, the energy it consumes?
So that's where proof of stake is really that's one of the, I think it's one of the reasons why Ethereum also wants to move over to this, is just because it actually does reduce the amount of processing power. Again, it comes back to what trade-offs do you want to have in your blockchain. But that's where I think it's, you know, it's one of the things that is always going to be one of the overarching, you know, potential criticisms of the ecosystem, which will also further, you know, increase the innovation that's happening to reduce the carbon footprint of such a system. Having said that, if you actually think about the benefit of a blockchain where theoretically all information within an industry is stored in one central place, you could also argue the alternative that now you no longer have it in 100 different places. Or stored in different places. Now, obviously, nodes also store copies of blockchains as well. So there are some considerations to be made there.
Another one is regarding raising money. How are currently blockchain projects raising money? In the past, we've had ICOs and STOs, IEOs, all these O's, and now how do they raise money?
So I'm going to start with how it's happening right now. Equity. That's the main way of doing it. And that's where ICOs were a thing in 2017, early 2018. But I highly doubt that we're going to see another ICO boom, purely because if you look at all the ICOs that happened, 99% of them have yet to deliver anything valuable. And as for the STOs, I'll let you take that question.
Yeah, the security token offerings were supposed to be a more legitimate way of raising funds, but a lot of them had regulatory issues. They couldn't meet the particular frameworks, or also the Security Exchange Commissions, for example, it's just too early stage to actually have a proper framework for legitimizing a security token offering round. So a lot of these STOs actually ended up not raising any money, or some of them even vanished. Some of them even raised money in the form of an ICO, right? And a similar application can be also said for initial exchange offerings. So a lot of blockchain projects are still getting money through traditional investments such as series rounds, seed rounds, or simply angel rounds as well. So yeah.
Then following up to that, right? How in the current blockchain world, how much is actually standalone blockchain projects that sells equity like this, and how much is actually corporate sponsored blockchain projects like the consortia? They don't really need to raise money, right? Because they get the money from the corporate themselves.
Yeah, so I would think most of the blockchain platforms, if we look at like layer one, the lowest level, I don't think there's been any real new major projects within the last, I would say, 18 months. These are still the ones existing from 2017, 2018. So they're still using the funds, but that's where now the challenge is, if you look at, for example, the economic incentives of the Bitcoin network, this is also going to be the challenge of these networks, is how do they move from external funding to becoming self-sufficient? In terms of the numbers, like I would still say, one of the challenges that we constantly face as a company is not every corporate shouts off the rooftops, hey, we're doing a corporate blockchain project, right? They keep it within themselves. So that's where from our data, it's still a high ratio, I would say maybe even 10 blockchain projects to one corporate project, maybe even higher. But this is something where we've spoken to companies, I think maybe Richmond as an example, you know, where they're like, yeah, we don't have any blockchain projects per se, but we've done a lot of experimentation with the technology. So that's where I think realistically also taking that Deloitte stat of 86%, if you would manage to find the statistics of exactly how many corporates there are, exactly, you could then say, okay, well, 86% of them are working on blockchain solutions. At least that's how we view the ecosystem. And if you would look at it in that case, I would then say, theoretically, there are actually more corporate projects than there are startup projects in the ecosystem.
Yeah, and then going back again to the innovative dilemma, I think a lot of the corporates take the approach of joining initiatives like consortia because they don't necessarily have to jump into the deep end. Because they don't necessarily have to jump into the deep end themselves, but they can actually, you know, jump on the wagon with someone else. And you see these corporate consortia becoming extremely large, right? We have some of them with over 350 members.
Yeah.
And that's because that's a way for them to have a view of the innovation that's happening in their specific field without having to go to the board of directors, get huge amounts of budgets, start these initiatives completely from the ground up in their own internal processes.
Mm.
Awesome. I think so far that's all the questions. If anyone else wants to ask a question, I've allowed you to unmute yourself. It's the admin superpower, so please feel free.
Unless it was well said.
I don't know.
Okay, what's your comment about Visa, MasterCard, PayPal withdrawing from Libra due to regulatory concern, which further hinders regulatory consequence of virtual currency? A tough one.
So Libra was probably the best thing that happened, I would say, last year, because it forced regulators to wake up. Now, I think it's also extremely logical to come to the conclusion that one of the largest companies in the world wanted to introduce its own currency. Like, that's one of the things where all the regulators went a little bit like, yeah, come on. So I think, directly answering your question, I think Visa, MasterCard, and PayPal, when they first heard about it, naturally they were like, okay, this is something that we want to be a part of because it's like a grand vision. You know, it's going to be bankrolled by a large company to kind of make it happen. But that's where, for the first time in the history of blockchain, the regulators really went, you've gone way too far. But that hasn't stopped Visa, MasterCard, and well, I'm not sure about PayPal, but Visa and MasterCard, we know for sure are still innovating in their own perspective blockchain environments and trying to also build their own kind of, let's say, crypto solution. But I think, maybe to summarize, the regulatory clarity that came after after Libra was a good thing.
Yes, there's finally a question not on finance. Could you please elaborate on the benefits and limitations of blockchain for supply chain transparency?
So the benefits really are having the digital twin of an asset. So it's kind of, I can't remember the first word, but it's like creation to grave of kind of the life cycle of a product. So that's where, you know, a product is created and then it gets shipped and it goes through all of these environments. But one of the problems is right now with, you know, how you and I kind of interact with goods is that at the moment of purchase, there is a hard stop on data transfer. As soon as there is money involved on a consumer side, there is no data transfer. So by having things like this digital twin, theoretically, there's going to be a lot more data that can be transferred, which could further help, for example, recycling and understanding all of the things that you might have. Then when you have things like carbon footprint tracking, you know, one of the big issues with things like that is you need to have a measurement device. That measurement device needs to be trusted, it needs to be certified, everyone needs to not tamper with it, and that tracking device can then put information into a blockchain network. Because you can't rely on self-reporting, as we've seen, for these types of things. So that there is what's called the Oracle problem. So that's, yeah, I don't know how to spell it, but that is kind of the main issue there. I don't know if you want to say anything else.
I also have another example. It's like, if you produce a certain product and you ship it to your end consumer, whether it's a company or a consumer, when there's a bad batch, for example, when there's something wrong with a specific batch of your product, often you have to basically get back everything that you've distributed over a certain amount of time. But when everything is tracked on the blockchain, and you can basically pinpoint exactly where that product is, where it has been, and you can actually just get that part of the product back instead of everything.
And this can all be done not just through a transfer of money, right? It can be done via deployment of a token or a smart contract, which means that the delivery was done from A to B. Whether that's from a trucking company that's delivered a large piece of cargo, or whether that's the actual accoutrement or the pieces that make up that product that would then be delivered into that supply chain. And you can take that same concept and apply that to trade finance. I know that's a bit more finance again, but the same in trade, especially post-trade, is pretty much almost identical with how blockchains operate with supply chain management as well.
Is blockchain currently used for combating illicit markets?
Yes, you could say yes and no. You could say yes in terms of KYC and compliance, or in terms of RegTech. But again, that wouldn't be called blockchain, because blockchain in our book is decentralized. It will be more a centralized distributed ledger type solution for KYC, know your customer, anti-money laundering solutions. In that case, it helps combat illicit markets. In other words, it also helps promote illicit markets if it's decentralized by nature as well, to be very honest with you guys.
Yeah, but if we're talking like in the supply chain aspect, I think that's where what one would hope to see is that companies participate in these networks for, provenance of whatever material that they're using, or kind of the brands that are there. So you can imagine, kind of, to make it into a real world example, if someone makes a handbag from Gucci, that Gucci handbag has maybe a QR code in it, and that QR code is a form of non-fungible token that acts as a certification, just saying a lot of words. But that is something that, is if there is mass adoption of that, it is going to be hard for illicit manufacturers to also get those certifications. Because again, if those certifications are managed in a permissioned chain, then there is going to be that guard where they're going to have to prove that they are actually the manufacturer. So that's where there are benefits to private chain solutions. And I think it's also important to point out, just because something's private, it doesn't mean that it's publicly accessible. Now, what do I mean by that is it can be private in the sense that not everyone can write to it, but it's public in the way that anyone can read from it. So that's going to be one of the really interesting use cases. But once again, it has to be that in an ideal world, 100% of all manufacturers are using these solutions to prove authenticity.
Yeah. To add on to that, before that node or that person can connect onto the network, there is a pre-qualification stack of what that contract must adhere to, right? So in order for that good to be put onto the network, it needs to already have some predetermined qualifications. For example, a legitimate good coming from a legitimate source. I don't know about illicit markets. Maybe you mean fake manufacturers like Gucci and stuff like this.
I think if you Google like diamond blockchain, there are stuff doing in this around diamonds, as well as also mining as well.
For provenance.
Yeah. So I think that there is some further reading that can be done to find solutions there.
Actually, you can check out.
Yeah, or you can check out our app, which lists all of these things.
Thank you for the reminder, Jonathan. Yes,
that's what it's there for.
We will be sharing about the app in the club, and we'll garner interest on that. Unfortunately, our time is up. Thank you so much, Jonathan, Vincent, and Lucas, for sparing the time and making this possible. We'll share the recording with the INSEAD students and with you, of course. And a pleasant day.
Yeah, thanks a lot. I hope everyone got something out of it. I know it was a lot of information in a short amount of time, but I hope it forms at least some basic understanding that you can then go and continue doing your research on. Thanks a lot, everyone.